Okay, hi everyone. Thanks for joining me. My name is Rob Baillie and I've been a developer for just over about 20 years, a lot of it outside of Salesforce, but the last 7 or 8 years inside Salesforce. And a lot of that time I've spent in sort of unit testing driven environments. And today what I'm going to talk about is mocking in Apex with big references to an open source toolkit, Amoss, which, full disclosure, I built, but don't worry, it is open source, it's fully free, MIT license, you're free to use it in any project that you want, so not actually selling you anything. And I really hope that you find this talk useful and it kind of gets you interested in the idea of mocking and using mocking in your unit tests, some of the capabilities it gives you. I'm going to be going over quite a few things in this talk, and they may not be in the order that we've got on screen. It's going to be a little bit of a journey around a few things, jumping around a little bit, because mocking is quite a big topic. And hopefully what I'm going to do is give you a bit of a flavor for what mocking is and what's possible in Apex, because a lot more is possible than you might imagine. And hopefully to really pique your interest in it and hopefully inspire you to try Amoss out or any of the other mocking frameworks that are available on Apex, and kind of try out and see what the capabilities are, as I say. Full warning, there will be code. It's impossible for us to talk about mocking without examples, really. It's not that it's a particularly complex thing, but I think the concepts are most easily explained with examples. So we're going to go through some examples. And there is a Git repo available with all of the examples and a few more things that I won't have time to go through, that you can then take away, have a look at after the talk, use those as your own resources for self-learning or for teaching other people, so on. Again, but MIT license on that as well, so free to use as much as you want. But before we start looking at code, I think the first thing we need to do is really define some terms. We tend to hear a lot of things to do with mocking out and about in the world. People say things like, oh, I'm going to mock that out, or I'm going to create a stub for that, or we can use a fake for that kind of thing. And what I find when I'm talking about mocking is that you find that there are a lot of terms which seem to overlap. They seem to mean the same thing, and not only that, but they seem to mean quite a lot. So mock can mean quite a lot of things, and stub can mean quite a lot of things. And whilst that's okay, it's not going to stop us from using technologies. It does kind of get in the way of us communicating about mocking and how we use them in unit tests. And the software developers, communication is a really big thing. Being able to define a concept with a small number of words is very useful. So what I'm going to do is I'm going to go through, as we go through this talk, I'll define a few terms that hopefully really start to tighten those meanings up a little bit for you and help them as an aid memoir for what the capabilities are, what the kind of things that you can do. I'm going to be using the definitions from Gerard Mazzaro's book, X-Unit Test Patterns, which is an absolutely brilliant book on different ways of unit testing, things that you can do in unit tests. And there's a great section in that on test doubles and mocking and how you can use them in different ways and when they're appropriate and so on. So I'm going to start off with that first term, which is mocking. We get our first term, which is a verb. And really what it means is it's the act of using a test double, where being a test-only replica of an object in a test in order for us to either simplify a test setup. Maybe we need a lot of data, maybe we need a lot of configuration. It takes a bit of work to get something up and running before we can execute a test. Mocking can help to reduce that complexity. It may be that it's to drive behavior of a system under test down a particular path. Some paths can be very hard for us to get code to drive into. Maybe we want exceptions to be thrown, and they're quite hard to generate from the rest of the system, or we want to get an invalid state that's quite hard to get to. Potentially, these states are impossible in the rest of our system. So we may write code that's quite defensive. So we might have methods that protect against invalid states, but the way we've written the rest of the system means that those states aren't actually possible to arrive at. Mocking can really help with that, so we can prove that those invalid states are handled properly, even though the rest of the system might not be able to do that. Another reason why I might do it is to validate the side effect that we may not otherwise be able to see. So sometimes we call methods on objects, but we don't get anything back from them. And all that happens is that method calls another method, calls another method, calls another method, and kind of 7 or 8 layers down, something happens. But we don't actually really see anything from the outside. In order for us to be able to validate that in a unit test, we may find that we have to delve deeply into those objects in order to find what the side effect was, or check that something was updated correctly in the system. But actually, it's so far away from the thing that we're testing, it feels like it's not ideal. Sometimes that's okay. Sometimes it's not that nesting isn't that deep and we're fine with it, but other times it can feel really uncomfortable. And that really leads us to the last point. Is a lot of the time we use mocking to reduce the brittleness. And that brittleness that I'm talking about is the brittleness that comes from not having isolated properly. And we may say that we want unit tests to be isolated, but when we introduce mocking, it's important for us to understand what we mean by isolation and why it is that we're doing that. And when we write unit tests without a mocking framework, what we have is a brittleness often that's associated with the change in behavior of the rest of the system. So we're testing class A and it requires class B, and class B changes. And what we find is that unit test for class A starts to fail because of its dependency on the behavior of class B. Introducing mocking allows us to remove that dependency and get rid of that brittleness. But what it will do is it will introduce a new type of brittleness into our tests. We become much more brittle on the interface of things. So as the interfaces of things that you're mocking change, then your tests start to break. And we may even find that we introduce a brittleness associated with the precise implementation of our methods. We test precisely what the method is going to do rather than what its behavior is. And we find that when we change that implementation, it breaks our test, even though the actual outcome is the same. So it's important when we think about that isolation and when we introduce mocking to understand where that brittleness is going to lie and where we're going to get the best payback in terms of long-term maintenance of our tests. But we'll go into that a little bit more detail as we look at the capabilities and some of the techniques that are available. In going through that definition, we've also mentioned something else. We mentioned a test double, and this is our first noun, our first entity in our mocking frameworks. And this is, I think, generally what people mean when they say a mock or a stub or a fake. It's basically, it is an object that is a replica of any other object in the system that you're testing. So that is, it's a test-only thing whose public interface is the same as a real world object or class. And we use it specifically for testing. Now, it may have hard-coded or behavior, or it may be configurable, but the important thing is it's that doubling up. And you use it in place of something else in your tests. And so, in summary, when we say we're going to mock something, what we're saying is we're going to use a test double in order to simplify our test. So what kind of thing can we use mocking for? And the short answer to that is, well, absolutely loads of stuff, really. If we're honest, I mean, pretty much anything that you can build inside a system can be mocked. But that's not really a very useful answer, is it? So it's probably time to start delving into some code. And so what I'm going to show you here is an example method, which we'll come back to as I start to describe some of the capabilities of mocking. And it's a pretty straightforward method. So I have a class customer order, and we look at this method, schedule delivery. What it does is it takes a list of delivery providers, and it will just loop over those delivery providers and find out if any of them can deliver to a given postcode in a delivery date. And if they can deliver, the first one it finds, it will ask it to schedule a delivery. And then it will return, given us the result of scheduled delivery. And if none can do the delivery, then it will just return false, say we couldn't do that. And if any exceptions are thrown, then something happens. Haven't implemented anything yet. Maybe we'll do some logging, something like that. And we would end up returning false because we haven't scheduled a delivery. Now, if we wanted to test this without using any kind of mocking or stubbing or any kind of test doubles, what we would find is that in order for us to really test what scheduled delivery does, we need to give it a delivery provider. And delivery providers may be quite varied things. We might have, say, a DHL delivery provider, which makes an HTTP call out to a service somewhere and returns a result from that. And that would be quite cumbersome to bring in something like that into our test. It might be that it makes a call out to some FSL functions to find out whether or not agents are available in a given team, that kind of thing. The point is, this method doesn't care what delivery providers do. All it cares about is it has a method can deliver and a method schedule delivery, and we can call those methods, and we can decide whether or not a delivery is going to be made based on the returns from those things. So when we're testing scheduled delivery, it feels like we shouldn't have to worry about what delivery providers do. And so that's what mocking is really good for, to remove that dependency on what other objects do. So if we were to just use some out-of-the-box functionality in order to do this mocking, how would we do that? Well, what you'll probably find from the most common to least common of these three techniques out in the wild, we might use HTTP mock callout. We might decide that actually it's okay to bring in that DHL delivery provider. We'd introduce an HTTP mock callout into there, and we'll drive its behavior through that. And that's not going to be great. I mean, it would probably work, but it's not great because our method doesn't use HTTP. So why would we care about HTTP mock callouts in our unit test? But it works, and it just proves the point that Salesforce does have some mocking capabilities out of the box. What we might do is we might implement a custom inner class inside our test. So we might have a delivery provider which is specific to our test. And that might be hard-coded with some behaviors. So we pass in certain parameters, we get certain responses back from it. It may be configurable, who knows, but it will be a class specific to our test that can give us the behaviors that we want. And actually, that's something that I would have done quite a lot in my PHP days, back in the day before PHP Unit and Simple Test arrived in that world. And it's certainly what I would have done in Salesforce before I built Amoss. And again, it works. It's not bad, but it works. Last up, and this is a really kind of powerful functionality in Salesforce, you really don't see much in the wild. It's stub provider. Salesforce comes with an interface that you can implement, which will handle method calls. And then you can instantiate any, pretty much any class in the system and give it this stub provider. And what will happen is any calls to methods on that class, on that object, will then get forwarded to the stub provider and get handled by that instead. And that's pretty powerful because it means that you can then create replicas of objects in your tests. But it does suffer from the same problem that the other two methods fall into, and that is that in order to get these to work, you need to implement a class. And what that means is you have a body of code that sits outside of your test method. And whilst you can write stuff to make it configurable in line in your methods, what you tend to find is people build these things in order to fulfill the purpose that you need inside a unit test. You don't always have time on projects to make things very generic. And so you end up with quite often tests which aren't particularly clear because they implement, they introduce an object which is may look like a mock, it may not look like a mock or a test double, and its behavior is kind of hidden somewhere else outside of the method. And that's really the problem that Amoss is trying to solve. So what actually is Amoss? Well, it's a library or a framework, whichever term you want to use, that we can use to build test doubles. And the point about it is it doesn't require test-specific classes to be defined. What we do instead is we define the behavior of our test doubles in line inside our test methods so that the behavior is explicit in our methods and it becomes hopefully very clear what it is that this object is doing and that it is a test double. The aim is for it to be as flexible as possible, so we can create lots of different types of test doubles, try to make it as intuitive as possible so they auto-complete on it, kind of guide you through the configurability of the objects as you're building them, and try to write it in a way that means that when we read this back, it's understandable. So hopefully we can read what this test double is doing, and even if you've never seen a mocking framework before, you can kind of understand what this thing is for and what it's trying to do. Under the hood, it utilizes stub provider. As I say, that is very powerful. It's very, very handy. It does have some limitations, unfortunately. So we can't create a test double for system classes or anything else outside of our namespace. And we can't create test doubles of inner classes. So you do have to promote things to full classes if you want to stub them or mock them. And we can't create any kind of test doubles for static methods, because you do have to have an instance that you can call against. So that is definitely worthwhile bearing in mind when you pick this up. So what kind of things can we build with Amoss or a mocking framework like this? The first thing is really the simplest thing, so a test stub. Now, this is a test double that is a replica of an object within a system that we're going to use inside a test. I mean, that's the definition of a test double. The main point about stub is it will exhibit absolutely no behavior other than to receive an input and then give you an output off the back of it. When we create one of these test stubs, it will give you the full public interface of the class that you're stubbing, but it doesn't actually do anything. It just returns things. So let's have a look at a piece of code that uses one of those. So we're going to test schedule delivery. And the first thing is we're going to do is we're going to create a stub. And so first of all, let's have a look at how we create one. So what we do is we instantiate an Amoss instance and we give it the class that we're going to implement with our test double. We're going to replicate. Then what we do is we ask this controller that we get back to generate us a double. We cast it into the right type, and then we end up with a variable, which is, as far as Apex is concerned, a delivery provider. So as I say, all of the public methods on that class are available for us to call. And if we call them, they will do nothing. And if they're supposed to return something, they'll return null. And that's slightly useful. We will often find that we write unit tests where we just want something that doesn't throw exceptions when we call it, or we can compile something. And we don't necessarily need it to really do anything or return us anything. But more often, we want it to return particular values. So in our situation, we want schedule delivery and can deliver to return particular values so we can drive our behavior down a particular route. So if we look at our next piece of code, this is how we would use it in that situation if we want to get particular values back from methods. So we instantiate our controller. We say we want a delivery provider. Then we tell that controller how to behave. So we say when can deliver is called, I want you to return true. And then also when schedule delivery is called, I want you to return true. We then generate a double from that, same as before. Then we can set up our customer order, start our test proper, call schedule delivery, and pass that delivery provider in. What we should find in our code then is can deliver gets called, that returns true. That means schedule delivery is going to get called, that returns true, and we get that value back out of our method. And so we should get true back in our response. And what we've done there is we've managed to test a particular path through that code without having to introduce any of our other objects from the rest of the system. We can just bring in a test double of the delivery provider and force it to behave in a particular way. Now, admittedly, in this particular test, that would pass if schedule delivery just returned true. So we probably want to prove other cases as well. So we might simply say that we have another delivery provider which just returns false when we call can deliver. And if that's a situation, we should get false back from our schedule delivery method. So we can do that. And we can layer on lots of variations in our test quite easily because we just reconfigure a different Amoss instance, a different controller, and our new test double, our new stub, will behave in a slightly different way. We may decide that that's not quite enough, and actually what we want to do is kind of check that the parameters are being passed properly. And what we can do is we can tell our controller to only return true if we get particular values in particular parameters. So in this case, we're saying the postcode has to be set to the postcode that's passed in, and the delivery date has to be the date that's passed in. Otherwise, what will happen is can deliver would return false. So when we do that, it might not be immediately apparent, but what we're really doing is we're now testing that the parameters are passed through correctly into our delivery providers. Because if we didn't get the right parameters passed through, then can deliver would return false, and this would return false. So we can add a little bit more complexity into that if we want to. On top of that, we can create multiple stubs. So what we can also do is generate one which cannot deliver and one that can. Now what we're doing is we're testing that we can loop over those individual delivery providers and make sure that as long as one of them can deliver and schedules it, that we get that one back. We could create as many of these as we wanted. We could actually tie lots of cannot delivery providers into the same controller if we wanted to. We will probably want to be a little bit wary of that because we do only have one instance of a controller. And so all of those method calls are being directed to the same controller. In some situations, that's perfectly fine. In other situations, it might not do quite what you expect it to. And we'll start to see some other behaviors in a minute, which will explain why that might be the case. but certainly we can test with lots of different objects at the same time. On top of that, as we were saying, we have some exception handling, and we might want to test what happens when our delivery providers throw exceptions. That's also very simple if you start using a mocking framework. We can just say when can deliver is called, we'll throw an exception. We can give it the exception that's going to be thrown, and we can do that, and we can make sure that we handle that properly. That can be really powerful in situations where it wouldn't have otherwise been possible for us to get exceptions to be thrown. So we can see that there's lots of different capabilities just if we're just talking about how stubs are going to behave. But we can do more than that. So we can layer a little bit more complexity onto our test doubles, and we can introduce the concept of a spy. So spies, where stubs are really good for making sure that we guide our code under test down a particular path. When it's not particularly great for checking that parameters are passed in the right way. We've seen that we can do that, but we do that through inference. If we want to be a little bit more explicit about that, then what we can do then is introduce a spy. And this is really good then for us, not just driving down a particular path, but validating that the right parameters have been called at the right time. So let's have a look at how that would be implemented in Amoss. So what we have is the configuration of an Amoss instance in exactly the same way as it was with a test stub, because actually Amoss doesn't care whether you're going to use something as a stub or a spy. It really matters how you use it. So we generate our double in the same way, we push it into our method under test in the same way. The difference is then once we've done that, we can then start to ask questions of the controller to tell us, well, what happened when this method was called, what parameters were passed into it at that time. So we have a call stack, which we can investigate any number of the method calls on our stack. So we can ask what's the first call of can deliver, what did you get in the postcode parameter or the delivery date postcode? We can count backwards, so we can say basically -1 is the last call, -2 is the penultimate call to schedule delivery. And we have a nice little shortcut for it, so we can very easily get to the latest call of something. And we can start to check whether parameters were passed correctly. And well, what's that used for? Well, you might just want to check, like in this kind of situation where we're just passing delivery date through and delivery postcode through, and we want to make sure that those go through properly. But it might be that our method actually sort of generates some parameters and passes those through, or it takes something in and it filters something and then passes that onto the layer below. So there might be some important functionality in there that we want to make sure is absolutely bang on. And this gives you a very simple way of checking that. And that's what spies are really good for, making sure that the parameters are passed correctly as you go into the rest of the system. But it doesn't just end there. So we have another capability which we can investigate, which is the mock object. And this is why I think one of the reasons why it's important for us to define the terms very, very tightly, because actually a mock object is a very particular type of testable. And it's a very evolved version of a spy, if you like. What a mock object can do, what it does over and above what a spy can do, is it can self-validate that they were used by the system under test in a particular way. So when we configure it, we don't just say, this is how I want you to behave. We configure them by saying, this is what you should expect to have happen to you, and it should happen in this precise order. We do it in a very similar way to our stub and our spy, except when we would have said when something happens, we now say we expect something to happen. And when we do that, what it will do is it will check that only the methods that we state have been called, that they've been called only with the parameters that we describe, if we describe any parameters, that those methods are executed in the precise order that we state, and that nothing else on that object is called. So let's have a look at that, because that's quite a lot to take in without an example. But it's actually very simple for us to set up. So here we have our delivery provider again as a mock object this time. And instead of saying when can deliver, we're going to say it expects can deliver, and then it expects scheduled delivery. And so what will happen now is when we call scheduled delivery against our order, if it doesn't call can deliver, but it calls scheduled delivery, then we'll get a failure because it would expect can deliver to be called first. If we call can deliver twice, it would fail the test because it expects it to only be called once. If we call anything else against our delivery provider, again, we would get a failure for that. Not only that, but once we've finished executing our system under test, we can then verify that the expected call stack is empty. So if we don't call scheduled delivery, then this would cause us to get a failure. And the really nice thing about this mock object is that when you do this, you remove a lot of the assertions that would otherwise be on the spy, called against the spy. So it gives you a very succinct way of describing a behavior. The only problem is when we do this, we do also create a very strict test. So this is now very much testing the very precise implementation of this method. And this is what I was saying earlier on about that exchange of brittleness. We've made a test which is actually very brittle to the particular implementation of this method. And so with that in mind, we do have to use these very sparingly. They are very good for a very particular use case where we have a particular algorithm or a particular process that we're following, and we want to make sure that that is precisely what is executed. And hopefully that algorithm is not kind of optimizable in such a way that we can reshape it and come up with the same outcome, but by calling a very different pattern of methods. Because if that is the case, then using something like this is probably not appropriate, because we will find that our test will need to change frequently. Okay, so those are mock objects. There are three main flavors of things that we can build with a mocking framework. But I guess a big question that we're likely to hear at this point is, well, yeah, but we don't actually write code like that in Salesforce. I'd say we probably should. We probably should more often than we do. But the reality is in Salesforce, what we tend to do is we sockle things out, we process them, and we do an update or an insert or a delete based on those results. And we tend to think of that as a very procedural thing. And a lot of the time what you find is, triggers have handlers, and handlers use a helper. And that helper has got a series of different processes that occur in this kind of way. We tend to think of it as being quite procedural. But Apex is object-oriented. And whilst this talk isn't really about how to write object-oriented code, right, that's an absolutely huge topic, it's very hard for you to use mocking or talk about mocking without also talking about object-oriented programming as well, and some of the things that you may need to do. So I think one of the things that we have to bear in mind is that even if we're just doing this sockle process update, we can split those things up. So we can split our data sources out. Just because we can have inline sockle wherever we want it, doesn't mean that we necessarily should. So we can do that. We can also split our DML out. We could implement a DML class, which we could then later mock if we wanted to. There are question marks on whether or not that would be a good idea, which I'm not going to go into, but the possibilities are there. And if we take a look at some code that's probably quite unusual for Salesforce overall, but I think actually makes quite a lot of sense. Here we have an opportunity product canceller, and this has a process method. And what this method is going to do is it's going to get a list of opportunity line items or opportunity products, and it's going to loop over those, and it's just going to set them to cancelled and say what date it's being cancelled on, and then return them, so that later on we can call get products to update against it and cause those to be updated in the database. So we look at how that might be used. Well, we simply have an opportunity product canceller. We configure it with a date for the cancellation. We set the data source. So we want unfulfilled opportunity products to be cancelled for some reason. Maybe this is coming in from a trigger, something like that. And we ask them to process. And the point is that what we have here is a data source which will give us our line items that we want to cancel. And we then have a separate DML outside of the processor. Now, why would we do that? Well, the point is, if we didn't do something like this, then in order for us to test this fairly simple piece of code, we would have to insert opportunity line items into our database. And in order to do that, we definitely need to create opportunities. We may have to create products and accounts and contacts. We've got products. We may need to create a price book and link that up with price book entries. Who knows what kind of processes are going to fire as we create all these separate objects? Who knows how much work is going to be involved in it? And yes, it's we've probably got data factories that help us to build these in our tests, but it takes time. And not only time to write, but it takes time to execute. We may find that we hit sockle limits because we're doing something quite unusual in Salesforce outside of testing, and we're creating lots of different types of things at the same time. So we can very easily hit sockle limits, and that can eat up implementation time. But not only that, when we execute that, that's going to take some time to run because it has to set up an awful lot of data. So one of the things that mocking can give you is that ability to really simplify that kind of piece of code, as long as you've split the way, the mechanism for getting the data out of the database somewhere else. So let's have a look at what a test might look like for this kind of processing pattern, if you like, if we don't have to put data in the database. So instead of that big lengthy setup where we call a lot of data factories to create a lot of objects or whatever, we just have to create a list of opportunity line items, which don't have to have any data in. Since these are never going to hit the database, we don't need to set them up in any particular way. We can just configure our mock object to expect get products to be called and to return this list of products, opportunity line items. And then we can pass that in as our data source. Then once we've executed it, we can check that we get the right number of updated products back out of here again. That's very useful here because what we're going to do is loop over those and make sure they're all cancelled and that the date of cancellation was set correctly. Obviously, if this didn't return anything in its list, then we wouldn't have anything to loop over and we wouldn't get any assertions, which means we wouldn't get any failures. So this kind of thing is kind of handy when we start testing processing to make sure we get the right, to make sure we get assertions, essentially. Now, if we just take a look at that, we can see that that's a much simpler test than it would have been if our opportunity product canceller did the whole job itself, because we were able to take that data source out of the equation and the data out of the equation. But not only that, that test is going to run significantly quicker. So while the original style test may take 7 or 8 seconds to run something in that kind of region, this test is probably going to take a couple of hundred milliseconds, if that. And if we extrapolate that over the whole of a test suite for a whole deployment, we could be shaving half an hour off a deployment time because the unit test is significantly quicker. Now, I would say if we are going to start using techniques like this, we probably want to make sure that we do also test this kind of processing with a real data source and with the update being issued as well, just to make sure that that data source marries up with what the processing requires and to make sure that the data is set up correctly in order to update it. But we don't need to do all of our tests in that style. We can just do a few of them, just to prove the point. Some eagle-eyed people out there may be going, yeah, well, this is all great, but we weren't referencing any formula fields and we weren't referencing any roll-up summaries. That's not really possible in memory. We can't do things like that. We have to start getting things out of the database. What if we have child objects in there, that kind of thing? Well, we can test in the same way, even though we have formula fields or roll-up summaries and so on and so forth. And within this test suite, there is a proof of that. With a variation of that process, which is a process with a bit of protection on it. So maybe this function, this method doesn't trust that what get product returns, and it always makes sure that only things that can be cancelled are cancelled. And if we look at this field, this is actually a formula field based on a pick list value. And in our test, we don't really want to leak how this is built. So we don't want to say that the status is a particular value. We want to prove that can be cancelled is the flag that's important, because that's actually how this is implemented. Well, what we can do in that situation then is pick up something like an S-object fabricator. And this is a great library that Matt Addy put together a few years ago, which I recommend you look at. There's a link to this at the end of the talk as well. And this allows us to build S-objects that would otherwise be impossible for us to set up. So normally we would not be able to set can be cancelled on an opportunity line item because it's a formula field, it's a read-only field. But because of the way this fabricated S-object library builds the S-objects for you, you can set them up and then convert them back into S-objects, and you get things with those flags set properly, or you can add parent relationships and child relationships into there as well without ever hitting the database, which is incredibly powerful. Then we can create very complex structures of S-objects and use them in our mocking framework to make sure that we can still get those capabilities even if we have read-only fields involved. Okay, as that test is available for you to take a look at. As I say, it's in the the sample repo. We can also use Amoss to build HTTP mock callouts, so we don't have to build specific classes in our test as well. There is another library out there that's absolutely brilliant as well. Nikita Chersin has built a very good library for this, and I'll have a link for that at the end of this talk. And he's got another talk in London's Calling on how to prevent defects during testing, on which he's going to be talking about tools. I recommend you watch that. I'm looking forward to watching that as well. And I should point out that Amoss does have plans to be able to handle HTTP mock callouts in a slightly neater way than it does at the moment. And so maybe Nikita and I will have a fight to the death at next London's Calling on which one's better. Watch this space, we'll see. So you may be thinking, well, actually that's all great, but my code isn't actually mockable. I see what you're doing and I like your ideas, but my code isn't mockable and I don't really know how to get there. Well, as I say, this isn't really a talk about object-oriented programming, but I guess there are a few things that you can think about. First of all, try splitting things up. We mentioned that before about splitting up data sources from processing, from DML. Try thinking about where those splits can be and where those responsibilities can lie in separate classes. A big part of that, I think, is you may find that you write a lot of static methods. Certainly if you write helper classes, you probably do. It's a good idea to start thinking about how you can sort of flip those things around. Instead of having a static method where you pass something in and you process over that thing, think about actually what would happen if you put that method on the thing instead, and you call the method against the thing and it processes itself. Just that little flick can really kind of open up what object-oriented programming really is and how you send messages between objects. And that really then helps to make things mockable, because as soon as that's an object that you have things against, you can then start to mock that. Also, even if you are writing object-oriented code, you might find that things aren't available for you to mock because you instantiate them in line inside your methods. And as soon as something is a variable inside a method and it's not really visible outside, mocking becomes impossible because you have to be able to say, use this version of this thing instead. So think about that and think, actually, instead of instantiating inside my method, can I pass them in as parameters? Or maybe can I pull it out and use a member variable and have a setter instead? Because if you can do that, and it does make sense, then you can then start to pass a mock version through instead. I do have code in the repository which kind of points these kinds of things out. And as soon as we get into that kind of world, you start to find that things are more complex to build up. You might want to then start thinking about factory methods and that kind of thing as well. So those are topics that are worth looking into. I did mention brittleness quite a bit, and there probably are some tips for anybody who's picking up a mock object framework for the first time to help you avoid brittleness in your tests. Because if you over mock, then you can very quickly end up with very brittle things. I think the first thing is try to avoid mocking the same thing in lots of different places. Because as I say, when you introduce a mocking framework and you introduce a test double, you tie your test up to the interface of the thing that you're creating a double for. And so if you have the same thing in lots and lots of tests that's being mocked, or you create stub of, then that expression of that API of that thing exists in a lot of different places. It's probably a bit of a warning flag that you've not quite got the right class structure as well, because you don't really want lots of things knowing about lots of things. You kind of want that compartmentalized. And so well-organized code does tend to lend itself to better mocking. But that said, it still happens if you're not aware of it. So avoid mocking the same thing in lots of different places. Make sure you're using the right kind of test double at the right time. So stubs, spies, and mocks are different in their usages. And so you do have to be aware when you want to use a test double, what is it I'm using this for? Why do I want it? Which technique is best for me? And so part of that is making sure you only test parameters when you need to test your parameters. If all you're doing is taking a parameter and passing it through to the next method down, you probably only need to test that once, because once you've proven it once, it's never going to be wrong. You only really need to test parameters multiple times if your method does something with those parameters and changes them in some way. As I was saying before, you only really want to explicitly test the order of things if you need to do that, if you want to prove that the order is precise. Because if you do a lot of testing where a precise order is described, then you will find that if you need to re-engineer things, that you suddenly find that you have to rewrite all your tests as well. So I guess in short, we're really kind of trying to focus on the behavior that we want within our tests, the direction we want to drive our code down, rather than what it is that object would normally do in the real world. We're trying to think less about the implementation and think more about the behavior of the class through driving its behavior using our testables. But the main thing is, don't overuse them. Mocking is not always the solution. Sometimes you do actually want to pull that dependency in because that's the simplest thing for us to do. So bear that in mind. Very quickly go over some of the extra capabilities of Amoss we didn't really talk about. So when I was checking parameters, I was always using set2. What that does is it checks that things are the same instance, which is brilliant for checking mutation of things to make sure that the right thing gets passed in so it can be mutated properly. But sometimes you want to just check that things are equal. Maybe your method builds something and passes it in. So we have that split of checking in Amoss. We have special methods for checking subject fields and list parameter values to make sure not everything in a list is of a certain shape or particular elements are set to particular values. We have things like that. We also have the ability to create a custom verifier. So if none of those capabilities are good enough for you, you can extend Amoss with your own verifiers. You do need a separate class for that. So I would avoid doing that if you don't need it. Similarly, with the methods, we have custom method handlers as well, so you can create those. And we have a very neat little thing. So sometimes you want an object that you want to say, nothing ever gets called against this. So we can do that. We can create something and say, I expect no calls to be called against this. And there's also something in between when and expect, which is allows. So that is where you want to be strict about what gets called, but you don't really care how many times it gets called or in what order it gets called. You can use allows to describe that as well. They're all worth exploring. But I think that's really it. I mean, what I've done is I've gone over quite a lot to do with mocking in quite a short space of time, but hopefully what I've done is given you a bit of interest in having a look to see what's out there. There's lots of repos that I've mentioned. So first of all, there is Amoss. That's available. It's also available as an unlocked package. There are notes on the repository on how you do that, how you can install it. All of the files that I've had in this presentation are also available, as well as some extra files that kind of describe some of the concepts a little bit more. The SObject Fabricator, I have a fork of that myself, which I'm enhancing what Matt Addy's done, and I love what Matt Addy's done. I'm just trying to tidy up the interface a little bit, so I like it a little bit better. That might be personal taste, but hopefully my fork will go into the core soon, but Matt Addy needs full, he's responsible for it. He is the person who's come with it. It's absolutely brilliant, and you should look at that. And also Nikita Chersen's framework for building mock HTTP servers. That's also brilliant, and it should be in anybody's toolbelt as well. And so I think that's it for me. Hopefully I've given you some things to think about and really kind of piqued your interest. So take a closer look at mocking. Maybe next time you're writing some unit tests, you'll have a look to see, well, actually, can I mock that? Why not? Let's have a go. And maybe it will help you think a little bit about how you structure your code so you can take advantage of it. And that's it from me. Thank you very much for listening.